This next objective continues on with describing relationships. So for every relationship defined by a set of ordered pairs, there's two important sets of elements, the x element and the y element. We call the x element the independent variable, and it's the domain. And then the y variable is your dependent, and it's the range. So if I give you a list of ordered pairs and I ask you, what is the domain? The domain is the set of x values. So it would be x equals, there's a 0, a -1, and a -1. So the set of x would be -1 and 0. If I looked at the range, it would be the set of y values. So the y values are 3, 2, and 3. So they are 2 and 3. For distinct points, you only get distinct points in your domain and range as well. If I gave it to you in a table of values, the domain for this set would be x equals -5, 0, and 5. And the range would be just 2. In corresponding or mapping, again, the domain is your x values. So if you look at the x values, you've got 0, 1, -1, 2, -2, 3, -3. So we're going to write them in order. I'm going to say it's -3, -2, -1, 0, 1, 2, and 3. And the range is -2, -1, 0, and 1. You'll notice as I went to the third one, I got lazy, and I got lazy, I'm noticing even just right here, halfway into the second one. The textbook won't put x equals and y equals. I always like to define the variable that I'm doing. You could do x such that x is, there's all these different forms of the statement. So the most simplified is just putting range is and then listing the numbers. A little bit more of a step up would be the set of y such or y is 2. An even bigger step up would be something like the set of y such that y is 2 and 3. There's lots of different ways of displaying your answer and sort of what you're comfortable with. But the important thing here is that the domain is the x values and the range are the y values. Okay, so that's from a list of points. Well, what if we made them into graphs? Well, this first one is just a graph of points. So your domain would still be a list of discrete points. So you have an x value here at -3, you have an x value here at 1, and again at 1, and you have an x value here at 4. So your domain would be the set of x such that x is -3, 1, and 4. The domain or the range is the set of y values. So you're looking at what y value points you have. So you have one here at -2, another one here at 1, another y value here at 3, and another y value here at 4. So it'd be -2, 1, 3, and 4. You'll notice when I found domain and range, I looked to where it hit the axes. So when I'm finding domain, I look at where your point would hit the x-axis, and when you're doing range, it's where your point would hit the y-axis. The second part of this question is it a function? So determine a function from a graph, you do the vertical line test. If I were to draw a vertical line here, I'd pass through 1, 2 points, so this is not a function. It is a relation, but the question just said, is it a function? This next one, we're going to go into domain and range, but what I want you to notice is that these are not discrete points. In fact, it's a whole series of x values that are possible for this and a whole series of y values that are possible for this. So before we go into doing these ones, I want to show you a little animation. So I'm going to start a slideshow here. And I'm going to just change so that you can see this part of it. And I want to show you sort of a visual representation of finding domain and range. So when you're finding domain, I said it's where your graph would hit the x-axis. So if you picture there being sort of like a light shining down, or some people think of it as like a grape press. I like the light. And it's where this graph would cast a shadow on the x-axis. And it starts here and even goes beyond here because the arrow goes down, and then it would cast shadows sort of all the way along here. So a visual representation of this would look like this. That graph, if you took it down onto the x-axis, would go flat from all the way to the right and all the way to the left. So we would say that the domain is the set of all real numbers in set notation. I would prefer to go XER. Or in interval notation, it would be negative infinity to infinity. If I wanted to look at this again, but this time I wanted to look at the range, you'd be looking at where the graph, so if you put a light here now, where the graph would cast a shadow. Now there's no graph below here. So you would start casting a shadow here, and it would cast a shadow up, 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 and continue through. So if I show you the animation, it's casting a shadow on the y-axis. But where did it start? It started here at 2. So in set notation, you'd say it's the set of y greater than or equal to 2. Or in interval notation, you'd go square bracket 2 to infinity. Okay, let's try another one. So this next one, similar idea. Okay, so we're looking at what would be the domain. So if I show you the x-axis projection, you're looking at where is this going to cast a shadow on the x-axis. And I like to kind of start in the middle of it. And I think, okay, it casts a shadow here and it keeps going, keeps going, keeps going, keeps going. And there's arrows, so it keeps going. And then from here, you can see that it would cast a shadow all the way along here. And then it keeps going, keeps going, keeps going, keeps going. So you can see the shadow would be cast all the way along the x-axis. So the domain, if I show you the animation, would be the set of all real numbers again. So it's the set of all real numbers or negative infinity to infinity. If I were to show you this again, but this time do the y-axis, so this was the x, right? It flattened down there. And if I go towards the y-axis, it flattens from -2 up into infinity. So looking at this graph, I would have a range of y is greater than or equal to -2, or square bracket -2 to infinity. So x-axis, you're looking at where it prints on the x-axis, there to there. And then range, you're looking at where it hits the y-axis. So it starts here, and then it would go all the way up. All right, next one. Sorry for the clunky display here. Okay. This one, we're looking at where it hits the x-axis. So sometimes I like to start at kind of like a weird point. And again, it would cast a shadow all the way this way. And then it would cast a shadow on the x-axis here all the way this way. So my domain would again be x is an element of the real number system, or all real numbers. And my set note or interval notation would be negative infinity to infinity. If I were to do this again and I looked at where is it going to hit the y-axis, you can see that it would be all the way along and along and along and along and along. In fact, it would hit all the way down and all the way up. So my range would be all real numbers in set notation, or negative infinity to infinity in interval notation. All right, one more. So if we look at this one, again, I'm looking at the domain. So I'm looking at where it starts hitting the x-axis. You can see what it would start casting a shadow here at -2, and it would continue along, 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 so that my domain is the set of all real numbers, is x is greater than or equal to -2, or in interval notation, square bracket -2 to infinity. If I wanted to look at the range, so this time I'm looking at where it hits the y-axis, you can see that it's going to start here. And then it goes up, 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 and it continues on forever. So if I wanted to say what the range of this graph was, I would say that it's -2 to infinity. So y is greater than or equal to -2, or square bracket -2 to infinity. So now that we've seen some of the animations, going back to this one, I want you to think of that same idea. Where would it hit the x-axis? So I can see that it's starting here, and then it hits all the way until here. So if this is 0, this is an x of -2, 1, 2, 3, and this is an x value of 4. So my domain in set notation would be -2 to 4. Oops, that doesn't look like a 4, does it? It looks like a 9. So 4. Or in interval notation, it would be square bracket -2 to to 4. Your choice, set notation or interval notation, whichever one you're comfortable with. The range, it's going to start hitting down here, and then it's going to hit all the way until you get up here. So again, this is -2, and this is 4. So the range would also be -2 up to 4. And the interval notation would look the same. So interval notation I'm not the biggest fan of, because unless you put the D and the R, I have no idea what you're talking about. So if you are going to use interval notation, make sure you put D and R. If you put the domain and the range in set notation, you include the X, and so I know, or the Y, so I know what you're talking about. All right, the last part of this is it a function? Well, it fails the vertical line test everywhere, so this is not a function. All right, looking at this one, the domain. So if I were to look at where it hits the x-axis, it would hit all the way along, all the way along. So the domain is the set of x is all real numbers, or -infinity to infinity. And the range starts down here at -2, and then it goes up and up and up and up and up forever. So the set notation would be y is greater than or equal to -2. Or interval notation, -2 up until infinity. Does this one pass the vertical line test? Yep, there's nowhere I can draw a vertical line and hit more than 1 point. So this graph is a function. All right, next 3, hopefully you feel confident enough that you could maybe pause the video and give it a go on your own, or maybe keep watching. So domain for this one, I'm looking at where it hits the x-axis. So you can see that it's hitting all the way along. This is where it stops. There's no graph to the right. So I'm going to say it goes from here over. So my domain is going to be the set of x such that it's less than or equal to 1, 2, 3. Oops, that looks like another bracket. Let's just make that nicer. 3. Or down to -infinity and up to 3 inclusive. My range, when I'm looking at the y-axis, I hit all the way along at the bottom, and then again all the way along up to the top. So my range would be the set of y as an element of the real number system, or -infinity to infinity. And then does this pass the vertical line test? No, it fails horribly everywhere. So this is not a function. All right, 2 more. Looking at the domain of this graph. So I'm always looking at where does the graph start? And so if you look at this one, I see that on the x-axis, it's starting down here at 0, and then it's going to the right. So my domain would be the set of x such that x is greater than or equal to 0. Or you could write it in interval notation, 0 up to infinity. And then the range, I'm looking at where it starts on the y-axis. It starts here at 1, and then it keeps going up. Anytime you see the arrow, just assume it keeps going. So it would be the set of y such that y is greater than or equal to 1, or square bracket 1 to infinity. Is this a function? Well, it passes the vertical line test everywhere I can check. So yes, this is a function. All right, last one is very similar to the circle in the top middle. So we're looking at where it stops and where it ends. So in the x values, it starts here and it ends here. So if this is 0, it goes to -1, 2, 3, 4. And then in the y value, or the positive direction, it goes 1, 2, 3, 4. So your domain is going to go from -4 up to 4. So it's one of those X sandwiches. In interval notation, it's -4 to 4. Those are square brackets. They just look round. My range, I'm looking at where it starts and ends. So it starts here, it ends here, and it's everything in between. So it's down to -1 and up to 1, 2, 3, 4. And so my range would be -1 up to 4, which in interval notation would just be -1 to 4. And is this a function? Well, it fails the vertical line test horribly, so it's not a function. So hopefully you feel okay with domain and range. If you're still struggling, there is tons of videos on the internet. If you look in project 1, I actually chose a domain and range video to analyze, so feel free to go and check that one out more. Just get comfortable with this. Some of you will get domain and range and it won't be a problem, you can see it. But if you're one of those people who are having troubles and you're not seeing it, you're not alone. Domain and range is a visual thing that it just seems like some people get it and some people don't. So if you don't, just keep working with it and find something that helps it make sense to you. And then hopefully you'll have that moment and go, oh, now I get it. All right, good luck.